Then we will be learning fluid mechanics. So what is a fluid? A fluid is a liquid or a gas. A liquid such as coffee, such as water, but a gas such as oxygen, such as nitrogen, such as such as water vapor. These are all examples. But think and tell me in the comment section below: is ice cream a fluid or is it a solid? Because an ice cream melts and becomes a liquid, but we eat it as a solid. So please tell me in the comment section below. So the meaning of a fluid is a substance that deforms continuously under the application of stress, no matter how small the shear stress be or tangential stress. There are two types, as I told you, and now we will see why will we study fluid mechanics. Why is it important to study fluid mechanics? So fluid mechanics is used everywhere, from going to space to riding a plane. You can ride a plane because of fluid mechanics. To drinking water, to to walking, everything that includes a fluid, because gas is a fluid, everything. So that's why we should study fluid mechanics. It is used in pumps, fans, blowers, compressors, turbines. They all need they all need basic knowledge of fluid mechanics. Even we need of slicing and hooking of golf balls can be explained by a principle of fluid mechanics. So that's why we need to learn what is fluid mechanics. Obviously, how vast is fluid mechanics, I cannot cover in even the 1,000 videos, but I will try to cover how much I can in this video. So in fluid mechanics, there will be 5 laws that will be applicable. The conservation of mass, Newton's second law, okay, principle of angular momentum, first law of thermodynamics, and second law of thermodynamics. Yeah, these 5 laws are going to be required. They will be applicable to any fluid. Okay, not all these laws will be applicable to solve any one problem, but we will need all of them. They will be applicable to all fluids. These are the 5 types. So now we will learn the methods of analysis. How will we solve a problem in this? So in basic mechanics, you remember we use FBD, free body diagrams. We will use here a system or control volume. Okay. So these concepts are almost they are identical to what you use in thermodynamics. Okay. So there you use closed system and open system. Here we use different things. So there is a system and control volume. A system is defined as a fixed and identifiable quantity of mass. Okay, a fixed and identifiable quantity of mass. So this is a piston cylinder assembly. This is the system boundary. Okay. So here there is a fixed identified quantity of mass. This the weight. The system boundary separates the system from the surrounding. Must be fixed or might be fixed or movable. Look, you can miss this. This is a piston, but no mass should cross the system boundaries. This gas cannot get separated. They are stuck in the system boundary, right? So this is from thermodynamics. I've taken this example, but we will if the gas is heated, you remember thermodynamics. If the gas is heated, the piston will go up because it will expand. The volume will be increased. PV is equal to nRT, right? So heat and work may cross the boundaries, but quantity of matter within the system boundaries will remain fixed. Okay, will remain fixed. Khatam. No mass will cross the system boundary. Heat and work can go, remember, but no quantity of mass will go. So I will give you an example. Okay, a question. So this is an example 1.1. First law application to closed system. A piston cylinder device containing 0.95 grams of oxygen initially at a temperature of 27 degrees Celsius. This is a diagram. 27 degrees Celsius or 300 degrees Kelvin. Okay. This is an operation due to the weight of 150 kilopascals or ABS. Okay. Uh, Heat is added to the gas until it reaches a temperature of 627 degrees Celsius. Okay. Are you understanding? 627 degrees Celsius. Determine the amount of heat added to the process. I am also giving a little bit from thermodynamics. I included heat here. Okay. So what are we given? We are given that the piston cylinder containing O2 has mass of 0.95 kg. Okay. The temperature is 27 degrees Celsius. T1, the original, and T2 is 627 degrees Celsius. So this is what 300 degrees Celsius. This is 900 degrees Kelvin. Sorry, not Celsius. Forgive me for my mistake. Kelvin. So what are the solutions? We need to find the amount of heat or Q1 to 2. So P is constant. What is it? 150 kilopascals. Right. So we are dealing with a system. We have mass is equal to 0.95 kg. The mass is same. Okay. We have the governing equation, that first law for the system of thermodynamics will use U12 minus W12 is equal to E2 minus E1. Look, physics is everything related. Okay. So now we will put it, we will solve it, we will do work done is equal to V1 to V1 P D is equal to P V1 to P. So ideal gas के लिए V PV is equal to MRT NRT. Okay. So we'll put it, and what will we get? We'll get answer as 518 kilojoules. Okay. Please try this problem. I'm just giving you the answer. I have not explained it that much fully because this is using thermodynamics and we want to mostly focus on for fluid mechanics. I am just showing the difference between thermodynamics and fluid mechanics with a question. Okay. Now we will start what is a fluid mechanics. So there are dimensions and units. So there is a system, as you know, MLT and SI units. So here we have the types of unit: density, specific weight, okay, specific gravity, and relative density. Right? And last but not least, we have we have density, we have specific weight, specific gravity, okay, relative density, and we have the specific weight, and we have the specific gravity. Okay, we have these all. So what is a density? A density is mass upon volume. This is mass upon volume. Specific weight is what? Specific weight is weight upon volume. So what is the difference, you might ask? So here, this is actually density is P, okay, the Greek symbol. So the density is P, and that is mass is kg upon meter cube, right? The SI unit. So this is P into G is called a specific weight, or lambda, means, yeah, lambda. This is specific weight. Then we have specific gravity. Okay, specific gravity is what? Specific gravity is the ratio of specific weight and the specific weight of pure water at 4 degrees Celsius. So we also denote it as SG, weight of substance, and the divided by the specific weight of pure water at 4 degrees Celsius. So what is this? Sg is equal to Pg upon Pwg 4 degrees Celsius at the rate of. So this is P upon Pw 4 degrees at the rate of. So this is 1000. So that's why we'll say the numerical value of specific gravity and the relative density is same. Okay, so what is relative density? Relative density is the ratio of density to the density of pure water at 4 degrees Celsius. So they are both the same thing. These are both unitless and dimensionless constants. So that's why we will not care about unit here. After this, we are going to be starting how to measure. Then we have three types. We have the length, the pressure, and the velocity. So you might ask, how will we have the length of a fluid? We don't have a length of a fluid, right? So think again. In a pipe, I have water going in. So what is the length of the fluid here? No, it's not the length of the pipe. It's the area of this, the top one. Okay, which is entering. That's the length. Similarly, pressure we must know that the pressure of fluid, we know this. And velocity, it gives away its name. The velocity of water when it's moving. Okay, so this is in what? This is in fluid dynamics. So what is fluid dynamics, you must ask? Fluid dynamics, there are two parts of fluid mechanics, fluid dynamics and fluid statics. So in every single type of mechanics, there are two types, dynamics and statics. That's why here dynamics is when it's moving and statics is when it's straight. Okay, that's the difference between dynamics and statics. Understood that much? Now we have these three parts, right? We have these three parts. So now we are done with the very, very basics. Now you might ask that these are all the measurement of the heaviness of a liquid. So how will we categorize uniquely how the fluid is? Because look, we have oil, हम लोग पास तेल है, हम लोग पास पानी है, उसका तो approximately same होता है value of density, पर behave बहुत differently करता है when flow होता है, right? So कुछ additional property होता है that describes the fluidity of a fluid. क्या नाम है? क्या नाम है? Viscosity. समझे? Viscosity. That is that describes the fluidity of a fluid. So this is called viscosity. We will not explain it in detail here. We will explain it later on. Also, this is also denoted by this mu du by dv. Okay, and this is called the absolute viscosity, mu. So now we will learn about what is a Newtonian fluid. So you must learn in shorts. You must be studying on shorts and saw that like if you put high pressure into it, so it becomes a solid and cracks. But if you don't put pressure on it, if you just put your hand lightly, then it doesn't crack. It is still a liquid. That is called a Newtonian fluid. It is an extremely, extremely, extremely viscous fluid. Okay. And we have non-Newtonian fluids like normal हम लोग के पास fluid है. ठीक है? Okay. So now we are done with the basics of fluid mechanics. We have learned what is the basics, what is the the units. Now we will go into we will start with the chapter. Okay. So now we will learn fluids at rest. So we have a tank of water open to the atmosphere. So as we know, any diver knows that the pressure increases when we go down. So I have a, I'll remove the water. I have a block. Okay. So here I have some force sitting down. I have some force upping, some force here, some force here. Okay. So that's why I will balance it with, um, I will balance it with equilibrium, and I will get that P is equal to P ought plus P3H. Okay, this is the formula. Now we have two types of pressure, an absolute pressure and a gauge pressure. So what's in an absolute pressure? Absolute pressure is the TSP, the total pressure. And gauge pressure is the absolute pressure minus the atmospheric pressure. So you might ask, how will we check atmospheric pressure? We will check it using a barometer. A barometer, okay? A barometer. So this is a very basic type of barometer. This is level 2. Okay. So we will substitute and we will get how to measure the pressure. Now I will want to start giving you the principles, because too much of easy we don't want to do. We will start with Pascal's principle. Pascal principle, you remember, you get a toothpaste. You squeeze one end of the tube to get the toothpaste out of another, because toothpaste is one type of fluid, right? So this is, you are watching what is a Pascal's principle. You are putting a small input. For example, I have a, this is a, this is the principle of pressure. This is open, okay? This is open. Open. So if you can see, this is opening is smaller than this. Here, this is a piston. I put some input. You must use it also in a car wrench. You see in a car wrench, they put little bit pressure, and the car, this one heavy car gets up. The same concept. You put a little bit pressure here, some Fi pressure. This is some small area, so Ai. So pressure is same. So it will become Fi upon Ai is equal to Ff upon Af. So you will multiply. So you will get Ff is very, very large, extremely large. If you put little bit more force and very, very you tiny there, so you'll get a much large output force. That is called Pascal's principle. Okay, that's it. What is Pascal's principle used? So this is Pascal's principle. Now we will go to Archimedes' principle. Okay, Archimedes' principle. Okay, so what Archimedes' principle? In Archimedes' principle, when a stationary body is completely submerged in a fluid, okay, like a hot air balloon is completely submerged. This is a fluid air, okay. So, or floating, that it is only partially submerged, like it is floating here. Or, you know, in the Kármán line, a spaceship is going, it's half in air, like that. That is called a buoyant force. The result fluid force that is there, na, that is called a buoyant force. That how you know how why airplanes fly. It is because of Archimedes' principle. Okay. So what is Archimedes' principle in its whole? So let us assume that there is a person swimming in a swimming pool. Okay, he's diving. He's and there is a sack. Okay, so he sees the sack and the contained water, and in static equilibrium, they are not rising, they are not sinking. Okay, there is a G going down, and there's a buoyant, and it's not going down. So there must be another force. What is the force? Buoyant force. Okay, that is called buoyant force. So what is buoyant force? It is due to the surrounding pressure of the water. Okay, if the net force is downwards, so the stone will oscillate downwards. If the net force is upwards, the wood will sit upwards. Okay, so we have this is called Archimedes' principle. So finally, we have what is the Archimedes principle? It is FB is equal to FFG. So then we have floating. So when we release a block of lightweight wood, okay, it is a lightweight wood, so it will float. Okay, so it will float just above. So the magnitude FB of buoyant force will be applied to only this much portion, and mg will apply fully. So we can say that FB is equal to FB full T, because it's not moving. And we know that FB is equal to MFG. So we'll get that MFG is equal to FG, right? So this will be floating. So in other words, the floating body replaces its own weight of the fluid. So now we will learn about apparent weight. Apparent weight in a fluid. So if we place a stone on a scale that is calibrated to measure weight, then the reading on the scale is the stone's weight. But if we do this, I'll explain you अच्छा से. So suppose मेरे पास है weight, weighting scale वाला, और यहाँ पर मैं stone रख दिया. कैलिब्रेटेड है, ओके, कंप्लीटली फाइन वेट है. तो मैं रख दिया हूँ अंडर उसको स्टोन को, तो इट विल गिव द करेक्ट वेट. ओके, नाउ आई डू द सेम थिंग बट अंडर. मैं स्विमिंग कर रहा हूँ और मैं कर रहा हूँ, गॉड नोज व्हाई आई एम डूइंग इट, पर मैं एक्सपेरिमेंट के लिए कर रहा हूँ. तो पर ये कम होगा बिकॉज बॉइंट फोर्स लग रहा है. तो हम लोग व्हाट इज यू टेल मी व्हाट वी फ्रॉम आउट ऑफ वेट, दैट इज द नॉर्मल फोर्स. ओके, तो इसमें नॉर्मल फोर्स कम होगा ना, बिकॉज वो बॉइंट फोर्स भी लग रहा है. तो अपेरेंट वेट क्या है? दिस इज एक्चुअल वेट अपॉन मैग्नीट्यूड ऑफ बॉयंट फोर्स और weight of minus FP. This is apparent weight. Okay. So in some strength wala test wala, you could do it more easily if you बहुत heavy stone है. Okay, you can do it more easily inside the stone then बाहर. So बाहर पर आपको डिफिकल्टी होगी, पर अंदर पर इफ आपके पास हायर बॉयंसी वाला है फ्लूइड, तो आप उसमें इजिली चला सकते हैं. समझे? Now till now we are not telling you. Now we will learn about two types of fluid: real fluid and ideal fluid. So what is the difference? In ideal fluid, it is uncompressible. Means I have, look, gases can be compressed, but we also know that liquid can be compressed till some range, right? Liquid can be also compressed, but to some range. So